I bet you didn't know that asking what came before the universe might not even make sense. Stay with us as we journey into the mystery of time, space, and the creation of the universe. Like and subscribe to explore more cosmic wonders with us. Imagine not just emptiness, but the absence of space, time, and matter, an ultimate void beyond comprehension. We often ask what happened before the Big Bang, but if time began with the universe, before has no meaning. It's like asking what's north of the North Pole. The question doesn't fit the reality. Science challenges us to let go of our intuition and consider that space, time, and everything else began together. There was no waiting, no prelude, because time itself didn't exist yet. The universe didn't appear in a void. It brought everything, including the void's alternative, with it. This is a humbling idea, pushing us to the limits of language and thought. The creation of the universe stands apart from every other event. It created the very framework of events. To understand our origins, we must set aside clocks and rulers, and imagine a realm where the laws of physics as we know them didn't yet apply. The real question isn't what came before, but from what state did time and space emerge? This shift in perspective opens the door to a deeper understanding of our cosmic origins. It prepares us to see the Big Bang not as an event in time but as the very beginning of time itself. 13.8 billion years ago, the universe began, not as an explosion in space but as the expansion of space itself. Every point in the universe was once compressed into a single, unimaginably dense point, a singularity. Then, in a fraction of a second, space itself began to stretch everywhere at once. Imagine dots on a balloon moving apart as it inflates. There's no center, just expansion everywhere. This was the birth of space and time, the true beginning of the cosmic story. As space expanded, it cooled, forming a hot soup of particles and energy. No atoms, no stars, just a glowing plasma. After hundreds of thousands of years, the universe cooled enough for atoms to form, mostly hydrogen and helium. Light could finally travel freely, creating the cosmic microwave background, the oldest light we can see. This afterglow is powerful evidence for the Big Bang, showing our universe began hot, dense, and has been expanding ever since. The formation of stars, galaxies, and eventually life all trace back to this explosive genesis of space-time. The universe's story began with the birth of space and time itself. What is time? For centuries, we saw it as a universal clock, ticking the same for everyone. Einstein changed everything, showing that time and space are woven together as space-time, a flexible, four-dimensional fabric. Gravity, he revealed, is the warping of this fabric by mass and energy. Imagine a heavy ball on a rubber sheet. It curves the surface and smaller objects follow those curves. Massive objects like stars bend space-time, and even light follows these curves. Gravity doesn't just shape space, it affects time itself. The stronger the gravity, the slower time passes. This is proven by GPS satellites and clocks near black holes. Time is not absolute, it's relative depending on your speed and gravity's pull. There's no single now for everyone. Your present is unique to your place in space-time. This malleable nature of time reveals a universe far stranger than our intuition suggests. Time is a dynamic dimension, sculpted by gravity and inseparable from space. The Big Bang explains how the universe evolved, but not what caused it. Scientists explore bold ideas, quantum fluctuations, where the universe emerges from a sea of quantum potential, the multiverse, where our universe is one bubble among countless others, and cyclical models, where universes are born and reborn in endless cycles. In the quantum view, nothing is a restless field where universes can spontaneously appear. The multiverse suggests our universe is just one of many, each with its own laws. Cyclical models imagine endless cycles of expansion and collapse. These theories are speculative, with no direct evidence yet, but they push the boundaries of what we can imagine about the ultimate origin. The search for answers continues at the intersection of physics and philosophy. The mystery of what, if anything, came before the Big Bang remains one of science's greatest frontiers. Why do we chase the origins of the universe? Not for practical gain, but because curiosity is at the heart of being human. We long to understand where we come from and our place in the cosmos. Looking at the night sky, we see not just stars, but history, light that's traveled millions or billions of years. This cosmic perspective humbles us, reminding us how brief our existence is on the universal timeline. Yet it also makes our lives more precious. The quest for knowledge drives innovation. Technologies from astronomy have transformed medicine, communication, and more. Exploring the universe pushes our intellect and inspires future generations. Ultimately, asking these questions fulfills our deepest potential. We are the universe's way of knowing itself. By seeking to understand the cosmos, we learn about ourselves and our capacity for wonder. We've uncovered much about the universe's story, from the Big Bang to the present, yet the biggest mysteries, what came before, what lies beyond, remain unsolved. Each generation builds on the last, standing on the shoulders of giants. Science is a process of questioning, testing, and refining, not a collection of final answers. The unknown, like dark matter and dark energy, invites new revolutions in understanding. When you look at the night sky, remember the story of the cosmos is still being written. We all play a part, even if it's just nurturing our sense of wonder. The journey of discovery has only just begun. If you loved this journey through space and time, hit like, share with your curious friends, and subscribe to our channel for more mind-expanding content. Until next time, keep looking up.